Hello, dear students. In this video, we are going to start the lesson that is reflection of light. In that, some of the important topics we are going to cover. Kindly share the link with your friends. Just for 2 minutes, I'm waiting. Okay. In case if you do not know any basics from the previous classes, you don't need to worry because I am going to cover from even 6th, 7th if you have not learned properly about light. From there, I am going to cover in this. Okay. So in short, with clear understanding, we'll try to cover. Okay, then let us go ahead without delay because I don't want to take your time as much as possible without stopping. We'll go ahead. Now, those who are willing to join, let them join later. Now, coming to first, the lesson light. It is most important topic because it carries what more marks as compared to other lessons, right? Here, problem will also come, right? And ray diagrams will also come, and some concepts based questions will also come. So you'll have to be very much careful and you have to study that in depth. Okay, that it becomes easy to understand. Now let us come to the lesson now. First, in light lesson, first we need to understand what is light. Light is simple very much. It is a form of energy, as you know already, which helps us to see the things around us. We know this, right? Now we have to understand little properties of light here. Light exhibits two properties we can say here. One is wave property, one more is what? Ray property. Okay. Here we are going to learn ray property of the light or ray nature of the light in this one. Okay, in this chapter. Coming to ray nature of light. Ray nature means we are just considering ray moves in the form of rays. Okay, rays of light we say, right? In that form we are going to study. Now coming to here, property of light. If you consider, light always travels in straight line. Okay, this you already studied in your previous classes, right? Light always travels in what? Straight line, right? Now we are going to learn about one of the most important concept of light, that is what? Reflection. First one, coming to reflection. First, let us try to understand what is reflection. Reflection is nothing but it is just bouncing back of light rays from a surface. Say for example, this is a surface. If light rays are falling on this, it is bouncing back, right? This bouncing back of light rays from a surface, don't need to think it must be only a polished surface. Okay, even if it is rough surface, then also what happens? Light will be bouncing back. Just it is, if you throw any ball, how it bounces back? That ball, football you take, cricket ball you take, right? It bounces. In the same way, if the light if it bounces from a surface, this property of the light, this phenomenon we call it as what? Reflection, right? Coming to reflection, you need to learn some of the most important things in this first. Okay, now here some of the terms which are related to this reflection of light we have to study, right? Before studying that, you have studied what? Plane mirror. If you take plane mirror, how are images formed by a plane mirror? That you have studied. That also we have to have a quick revision. Now let us take, this is a plane mirror, right? What happens? You have to say the properties. It's very simple. Don't need to by heart, simply don't memorize. Instead, just you understand. Just if you stand in front of the mirror, how do you look? You always look what? Erect. Erect means as it is, straight. Okay, if it is this one is called erect. If I make it upside down, that is called inverted. These terms you must know first, right? This is erect, straight. If you make it upside down, it is inverted, right? That is erect image. Ours is erect image. Now you see, you can see the image in the mirror, but you cannot get this image on a screen, right? Then such type of image which can be seen in the mirror but cannot be caught on a screen. If it cannot be caught on a screen, if it can be seen in the mirror, we call such type of image as virtual image, right? Virtual image. If you can get it on a screen, then it is called, what do we call for that? Real image, right? Then when we are standing in front of the plane mirror at houses, what happens? We see our erect, and in what erect image we find, and virtual image. These two properties we see. Next, you see one more property, very simple. If you are standing in front of the mirror, how do you see yourself? Do you look big or small in that? Your image will be similar to your height, right? Height of your image, height of your image or your body, both they are equal. So what we can say, height of the object and height of the image both are same. Okay, here both are same. Next, coming to height of the image over. So in case if anybody is asking any question, just I am going through this also. Meanwhile, I'll be seeing your charts in case if it is required. Okay, then. So what we can say, height of the image, height of the object, both are same. Next, what we can say here, other than that, if you take any object and place it in front of the plane mirror, okay, what happens? Now we can see 1 centimeter distance is there. What? Object from the mirror, right? If you move it away from the mirror, what happens? Chalk piece is also moving away from the mirror, right? Okay, means what? It is moving behind the mirror. So what we can say, what distance is there between the object and the mirror? Same distance is between the image and the mirror behind it. So how to say this one? The distance of the object in front of the mirror is equal to the distance of the image behind it, right? This is next property we can say, right? Next, other than this, what we can say, uh, distance over size over, right? And it is erect I said, and virtual image I said. Next, one more is there, last. What is that? Always when we are eating, if you are using your right hand, it looks like left hand in the mirror, right? It's simple one. This is called what? Lateral inversion. This is one more property of the plane mirror. Very simple. Okay, these you don't need to buy at all these things, they are very much simple ones, right? So this is all about a plane mirror. Now coming to reflection. In reflection, you need to understand some of the things. They are very much important here. You will not be having idea of what the terms related to the reflection. Because of that, it becomes later what difficulty in solving the problems based on that. First, let us get it clarified here. How? Just you see this ray and this ray. This is called incident ray. This is called reflected ray, and this is called what? Mirror we show like this. Okay, what I'm drawing the lines, that is rough surface, up one is what? Polished surface. To the surface, always we imagine a perpendicular line here, okay, to the surface of reflection. This perpendicular line we call this as what? Normal. Okay, this is called normal. Next, coming to this ray which is first falling on the surface, that is called incident ray. Okay, we call this as incident ray. Now coming to this ray which is reflected, we call this as what? Reflected ray. Okay, this is reflected ray. Now this normal and the incident ray, between these there is angle, right? This is making an angle with a normal. Okay, this angle made by the incident ray with the normal is denoted by I, and we call this as what? Angle of incidence. Angle of incidence we say. This is called angle of incidence. Which one? Here, this one I'll show here. Okay, this is angle of incidence, this I. And here also angle is made by reflected ray, right, with the normal. This is called what? Angle of reflection. That is called angle of reflection. You must know these terms first, right? This is normal. This is called what? Point of incidence. We call this one as point of incidence. It is a point where light is incident first. That is called point of incidence, right? Yes, we learned this. This is rough surface of the mirror, and up one is polished surface of the mirror, right? Now coming to here, all these things we learned. After learning this, we can understand what are two laws of reflection. That is very much clear to us now. Okay, easily we can understand. How to state that? Let us go ahead with that. Now, okay, under reflection we are studying now first, right? Yeah. Now, in reflection, laws of reflection. In that, laws of reflection we are writing. Reflection. Two laws of reflection are there. What is that? As we studied here already, this is incident ray, this is what? Reflected ray, right? This is point of incidence and this is normal at the point of incidence, right? Now this is angle of incidence, this is angle of reflection, right? This is incident ray, this is reflected ray. We are showing this is mirror as in already, right? And this is what? Normal. These are required for us. Now, first law, okay, first law, what it says? Laws of reflection. It says the angle of incidence is always equal to the angle of reflection. Means at what angle light is making with this normal, same angle is made by reflected ray after reflection with a normal. Okay, if it is 30°, the angle between incident ray and the normal is 30°. This will also be equal to 30°. If you make this 15°, that will in way what decrease in the angle. If you make it 15, this will also be 15. If you increase 60, if you make here also 60. So what we can say, the angle of incidence, the angle of incidence, the angle of incidence is always equal to the angle of reflection, the angle of reflection. Okay, we can say this is first law. How to say this one? Angle of incidence is always equal to angle of reflection in simple form, right? This is first law of reflection. Next, coming to second law. In case if you have any doubts, you can ask me. I'm going to the chats. Okay, then. Now you see, coming to second law, what it says? Very simple here. Here you see, this is incident ray, this is normal, this is reflected ray, this is point of incidence. Okay, point of incidence. Taking these, we are defining. Okay, we are giving that second law. How to state that? See, the incident ray, okay, the normal at the point of incidence and the reflected ray all lie in the same plane. Okay, it's very simple. What? The incident ray, the normal at the point of incidence, and the reflected ray, all lie in the same plane. This is second law of reflection. This you must remember. It may be asked at least 1 or 2 marks, right? You have to remember those. So next, after that, see, same plane means you see here this board is plane. This one ray is also not coming out of the board, and it is not going out inside the board also. It is just on this plane. So that is why we consider this as a plane. Okay, remember. This is second rule. Okay, means first law, second law of reflection, we can say. Right. Now coming to, we studied what are laws of reflection. We studied reflection through plane mirror. We studied in plane mirror how that image is formed. We learned already, right? Taking that example. Next, we are going to learn about spherical mirror. From here, your real topic begins of class 10th. Okay, in spherical mirror, first you need to understand some of the basics which are related to the spherical mirrors. If you understand those concepts, only then you'll be able to solve the problems based on that, right? Yes, coming to this, let us go ahead with one thing, that is spherical mirror. Spherical mirror. First you need to understand what are spherical mirrors, right? You need to what define it. Spherical mirror means what? Spherical mirror means what? The mirror whose reflecting surface is curved, that is only called spherical mirror. That curved surface we are considering it as spherical one. Okay. So what we can say? The mirror, okay, the mirror whose reflecting surface, whose reflecting surface is curved, is curved, is called a spherical mirror. Spherical mirror, right? In spherical mirror, we are going to learn different types. Okay, how? Here, a spherical mirror. If I give a little bit of clearance or clarification, here you see, if this is a sphere, okay, if you cut one part of this, you are getting like this cut part, right? This part, what we are getting here, hollow sphere you have to cut. Okay, inside this curved surface, say for example, here it is reflecting one. This surface is curved or not? Then we can call this as what? A spherical mirror. Okay, and it may be sometimes here it may be polished, other side this side, whatever it is, that will come to know that one first. Okay, after learning this, let us come to know what are different types of spherical mirrors here. First, let us study in that. First type is what? Concave mirror. Concave mirror, right? Next, second one comes what? Convex mirror. Two types are there. Convex mirror. First, let us understand how to define a concave mirror first. Okay, if you take concave mirror will define. Okay, very simple. A spherical mirror whose reflecting surface is curved inwards. Curved inwards means this is curve, right? Inwards, it is what? A polished surface is curved inwards. That type of, here, look at this, here mirror it is, right? Look at this. This is one mirror. This is concave mirror. Here reflecting surface is curved inwards, like this it is there, right? Inside. Here this is bulged outside. This is rough one. Remember, okay? This is curved inside. So that is why what we can say, uh, a spherical mirror, a spherical mirror whose reflecting surface is curved inwards, curved inwards is called is called is called a concave mirror, right? Very simple. Next, here, what is convex mirror then? You have to define that also. Convex mirror, what? A spherical mirror, same. I don't want to write that one, just to change here. A spherical mirror whose reflecting surface is curved outwards, you make, finished. Okay, here it is curved inwards. If it is curved outwards, then it is called what? Convex mirror. Say for example, you can look at this. Here this reflecting surface is curved outside. Here this surface is what? Polished, means we can see the image on this here also. Okay, so here what happened? Rough surface is curved inwards, but the smooth surface, polished surface is curved outwards. Then this type of mirror is called what? Convex mirror. Okay, yes. Next, after this, let us go ahead with concave mirror, convex mirror. Now we are going to learn about the important terms related to this spherical mirrors. What is that? Coming to here, terms related to spherical mirrors, spherical mirrors, right? Now, if you take any spherical mirror and if you focus the light at one point, okay, what happens all the light will be converging at one point. Say for example, this is the mirror. Okay, here any source of light is there. Okay, source of light is there. What you do is you converge the light. Okay, light rays, if they are parallel, okay, these light rays, what happens, they are parallel. Okay, if you take here where they converge, what they are making after converging, all those we need to learn, right? Now we can see here, coming to this reflecting surface of this concave or convex mirror. Now this is concave mirror. If you put a drop of water in this, it settles at the center, right? It comes to the center. So that center of the mirror is called what? Pole of the mirror. We call this as P, that is pole of the mirror, right? Now this mirror, let us denote it as Mn. Okay. Now this is pole of the mirror. Now this mirror, how we are getting? It is part of a sphere, right? This is a sphere. This mirror is part of it, right? Here it has center, right? So we will remove this. This sphere has center, right? So we call this center of the sphere from which this mirror has come. That center is called center of curvature. We call this as center of curvature, right? That is called center of curvature. Means what we can say? Here it has center of curvature, we can say. That is denoted by C, right? Center of curvature. Next, what happens? The rays of light, if you take, okay, here one line we have to imagine in that middle imaginary line which is passing through the center of curvature and pole of the mirror. We call this line as what? Principal axis. Okay, we call this as principal axis. See, and this mirror should be denoted like this. Rough surface should be shown here. If I have shown here concave mirror, the other side has to be rough surface. You have to show that one. Now the rays of light, if you consider, if they are parallel, after reflection they meet at a point, okay, on the principal axis. They meet at a point on the principal axis. Okay, one more ray if you take, that will also come and merge here. One more ray after reflection, that will also come and merge here. Okay, this point where all the rays meet on the principal axis, this is called what? Principal focus. Okay, or we call this as focal point. Okay, it is denoted by F. We call this as principal focus. Principal focus, right? It's very simple. All the rays where they meet each other in the principal axis, that point is called what? Focal point or principal focus, right? Okay, we'll do 50. I'll come to yours. So now what happens? This is principal focus, right? Huh. Now this is a point, right? After this, what we are taking, these rays which are parallel, they are combining or they are meeting at a point on the principal axis. This is called principal focus. This is center of curvature, right? This is pole of the mirror. Okay, all these terms you must know. Now there is effective diameter of this curved surface. Okay, from here to here, if you consider this effective diameter of this curved surface, that is called aperture. Aperture of the mirror. We are considering here only the mirrors of a small aperture. Okay, that type of mirrors we are considering here. Mirrors of small aperture we are considering. Remember, all these terms, if you get it clarified first once, it becomes very much easy later to draw the ray diagrams. Okay, now these are the terms related to this concave mirror. And what about convex mirror then? If you take convex mirror, here light rays, what they will become after they are incident, they are diverging. Okay, this also has principal focus, or whatever principal axis, and here also it has principal focus. Here in case of what, here you need to show rough surface, right? For convex mirror, here what happens, light rays after they are incident, they are diverging away. Okay, when they are diverging, what happens here, principal focus, if you consider how it comes, these rays they are appearing to be diverging from a point on the principal axis, right? This point we call it as what, principal focus. Means what, here principal focus is behind the mirror in case of what, convex mirror. In case of convex mirror, it is behind the mirror, right? If you denote this as mn, right? And center of curvature, where does it come? That should also be behind the mirror, right? Here what principal focus is there, double the length of this, here we will have center of curvature. Okay, now one more term you need to learn. What is that? Here the distance between this principal focus and pole of the mirror, we call this as focal length, and it is denoted by small f. Okay, this is focal length of the mirror. Focal length means it is the distance at which image is formed, right? So that is only focal length we can say here. Means all the rays they meet each other on the principal focus. Okay, so now what we can say here, okay, means it is the point on the principal axis. Okay, we know that principal focus, the distance between pole and that principal focus is called focal length. That is also over. Next, after this, what do we need to understand? These are all over. Okay, terms related to the concave and convex mirror we learned now, that is spherical mirrors. Now we have to go ahead with one more, that is the laws of drawing the ray diagrams. Okay, how to draw the ray diagrams, that is also important, so we have to learn that now. So we'll remove this and see how to draw the ray diagrams. For this, some rules are there, you need to follow that. Okay, for concave mirror and convex mirror, for both. First one, okay, first rule, it says, what is that? Rule one, in that, if you consider a concave mirror, okay, if you consider a concave mirror like this, you need to show, say this is mn mirror. Okay, mn, here you have to show the principal axis, that is imaginary line passing through the center of curvature and the pole of the mirror, right? And in between comes what, principal focus, right? If you consider, in case of concave mirror, if a ray is parallel to the principal axis, okay, this is the rule, after reflection it passes through the principal focus. Okay, this is the rule in case of concave mirror. If it is parallel, principal focus passing through principal focus, you have to show this one like this, right? Now you can show here with this one dotted line, you can show this is phase what, normal, this center of curvature to this point on this, say for example this is d, then this ray cd will be normal to the reflecting surface. Okay, angle of incidence, angle of reflection, both will be obeying the laws of reflection, that you must understand. So this is first rule. Okay, and this is for concave mirror. What about convex mirror then? In convex mirror, what happens? If you consider convex mirror, for this also principal axis, right? If a ray is parallel to the principal axis, after reflection, what happens? It diverges. How it diverges? It appears to be diverging from a point on the principal focus, right? So what we can say is, here, if it is parallel, it appears to be diverging from the principal focus. You can see here, if it is parallel, it is passing through the principal focus, right? Here, if it is parallel, it appears to be diverging from the principal focus. This you must learn, right? This is pole, this is mirror, mn. Here comes what, radius of curvature, we can say. Okay, this is first rule. Coming to second rule. Second rule, what does it say? Very much simple. If you learn one rule is free for you. Okay, because learning one, the other one becomes very much simple and easy. How? If a ray of light is, if a ray of light is, let us take this concave mirror first. Okay, if a ray of light is already passing through the principal focus F, this is C, center of curvature. If a ray of light is already passing through the center of the principal focus, after reflection, it emerges parallel to the principal axis in case of concave mirror. Remember, in case of concave mirror, it emerges parallel to the principal axis, right? And here light rays which are moving, they are coming back in the same direction along the principal axis. Now what we can say, this is in case of what, here you can show with the help of this center of curvature, this will be the normal. Okay, this is the normal. Next, coming to in case of convex mirror, what happens then? Here this is convex mirror, right? This also has principal axis, and here you need to show, what you need to show, a ray of light which is appearing to be passing through the principal focus. Look at this here, F. If it is appearing to be passing through the principal focus, okay, after reflection, what happens? See, it is appearing to be passing through principal focus. After reflection, it emerges parallel to the principal axis, right? It emerges parallel to the principal axis, right? This will be pole, this is F, this is C, right? Again, and here you can show one more dotted line. With the help of dotted line, we can show here it passes through the principal outer center of curvature. See, this will be the normal, right? This normal says the laws of reflection is obeyed by both the rays, right? That is reflected and incident. So this is how we can say that. Yes. Next, after that, uh, let us come to third rule. Very simple one there. Okay, all these rules, if you know, then drawing the ray diagrams becomes very simple. Okay, when we draw that, you will understand. Okay. Now coming to third rule. Third rule, what it says, rule 3. Here, if you draw the concave mirror, in case of concave mirror, right? This is principal axis, right? Here, this is principal focus, this is center of curvature, right? Now, a ray of light, if it is passing through the center of curvature, okay, it follows the same path. You take whichever, from here you take, from here you take, whatever, no problem. Okay, if you consider this type ray, no problem. It follows the same path after reflection. Look at this. Okay, if it, because it is like normal to the reflecting surface, if it is passing through the center of curvature, it follows the same path after reflection. It does not change the direction. Remember, this is in case of what? This is in case of concave mirror. You have to show these all, right? Next, coming to convex mirror. In convex mirror, what happens? This same. This is convex mirror. This is principal axis, right? Here, look at this. This is, say for example, F. This is C, right? Center of curvature. Now, if you are imagining any ray of light passing through the center of curvature, right? After reflection, it follows the same path. See, this is how you need to show. Okay, pole and all you have to show. Okay, so this is the third rule. Very simple one, right? Next, coming to fourth rule 4. What it says, if you take one concave mirror, okay, rule 4, it says this is principal axis. Okay, see how simple it is. Now if you say this as principal focus, this as center of curvature, you consider any ray which is incident obliquely towards pole P. Okay, if it is oblique towards pole P and it emerges obliquely after reflection, okay, obliquely, then what is important here? Then you have to show it obeys the laws of reflection, that is angle of incidence will be equal to angle of reflection. right? It obeys the laws of reflection. So this you need to show. So this is in case of what? Concave mirror. If you come to the same one, in case of convex mirror, what happens? Here you need to show convex mirror, right? Here this is principal axis. Okay. So how to show this? A ray of light which is incident obliquely towards pole P. It's not coming properly. Okay. Okay, it emerges obliquely after reflection in case of convex mirror. Here also laws of reflection is obeyed. That is, angle of incidence will always be equal to angle of reflection. Remember. Okay. And its principal focus is behind the mirror. Center of curvature is behind the mirror. Okay. This total distance, as we already studied, what is this? The distance between pole and center of curvature. We call this as what? Radius of curvature. Okay, this is r, denoted by r. And this distance between pole and focus, principal focus, that is called f. It is denoted by small f, that is focal length. Remember. Okay, focal length means the distance between principal focus and pole of the mirror, right? And if you say what is radius of curvature, it is the distance between pole of the mirror to the center of curvature of that particular mirror. It may be convex or concave, right? And if you take concave mirror, principal focus, right, and the center of curvature, they lie behind the mirror, right? And the focal length and radius of curvature, they too lie behind the mirror. But if you take in case of concave mirror, what happens? The principal focus is in front of the mirror, radius of curvature is also in front of the mirror, center of curvature is also in front of the mirror, principal focus also, right? All these things, they are coming in front of the mirror in case of concave mirrors, right? Okay, then next, these are all about okay, how to draw the ray diagrams. Next, after this, let us go ahead with how to draw the ray diagrams for image formation by concave mirrors. Okay, image formation will be there. How to draw the ray diagrams for them? Okay, so let us come to know. Okay, ray diagrams for concave mirror. We are considering only concave mirror. If you come to concave mirror, first one, we should consider the object at infinity. At infinity means what? At a larger distance, largest, okay, too much far away from the earth, we can say that. Okay, like that. At infinite distance, we are considering, right? So, what to say? For example, if you take sun, it is considered as at infinity, right? First, you should draw like this ray diagram. Let us take when the object is at infinity. One by one, we will understand here. Okay, when object object at infinity, when you take like this, you have to draw the mirror, that is concave mirror, like this. You have to show the rough surface the other side, and here the principal axis, right? Now this has to be named as EMN mirror. Let us denote this as pole of the mirror, that is P. Let this be what? Principal focus F, and double the length of this will be center of curvature, right? Here comes center of curvature. Now if you consider any object at infinity, it is taken like this, below and above the principal axis, and rays, parallel rays you are considering, these parallel rays. Okay, here also one parallel ray. After reflection, they meet at a point, okay, on the principal axis, that is principal focus. Here they join. Okay, now, so what we can say here, when the object is at infinity, look at this. These rays which are moving along this principal axis, they follow the same path, okay, because it is normal. Now what we can say is here, the light rays which are parallel to the principal axis, okay, how they are coming. When the object is at infinity, we are considering the rays of light coming from that object are considered to be parallel. These parallel rays, since they are parallel to the principal axis, they are combining at the principal focus. Why they are combining at the principal focus? Just now we have studied this under rules. What did it say? First rule, it said if a ray of light is parallel to the principal axis, in case of concave mirror, it passes through the principal focus. We learned this law or not first? Same we are, and we're going to apply the same rule here also. So if it is parallel, it should pass through principal focus, right? Here, then what we can say here, at the principal focus, image is formed. If the image is formed at the principal focus, you have to say here position. Where is the position of the image? It is at F. Image is, okay, image is at F. It is formed at F. Next, what is the size? Size is what? Highly diminished. Highly diminished. Okay, diminished. Highly diminished means point sized it is. Point sized we can say. Then what about this one? Point sized. After this, uh, coming to nature. What is the nature of the image? If these are asked, you have to write like this. Nature of the image is what? It is always, it is real and inverted. Real and inverted, right? These are different characteristics of the images when the object is at infinity, right? Next, we have to go ahead with uh, when the object is not at infinity, beyond C we need to consider. Okay, let us take when the object is beyond C. Okay, object is at infinity over, when the object is beyond C we have to consider. Beyond C. Beyond C means if you consider a concave mirror like this, right? This is the concave mirror, right? This is the principal axis. If you consider this, here principal focus, right? This will be center of curvature will take. Beyond C means, is it visible to you? I hope it is visible. Just a minute. Is it? It can be seen. It is visible, of course. So what we can say is, here you have to consider the object. This is denoted as AB, right? Object. This is MN, and this is P, pole. F, this is C, right? When it is beyond C, we have to consider, it is a little difficult draw because if it goes behind, you will not be able to see. I will shift the image this side a little bit. Okay, see, one by one I'll show. It becomes easy. Okay, now this is F, this is C, right? If you are considering the object beyond C, here you have to consider, right? When it is beyond C, this is C, this is pole. Okay, this is the concave mirror that is denoted by MN, right? If you consider a ray of light passing through C, first you need to consider a ray of light passing through center of curvature, okay, C, and one more ray, it should be parallel. One is parallel, one is passing through C, right? Now you can see here a ray which is parallel, it should pass through our principal focus, right? It is passing through the principal focus, right? And here a ray which is passing through the center of curvature, it follows the same path after reflection, right? See, if it follows the same path, and at this position where these two rays they intersect each other, at this position we get the image. You can see here it is upside down, so here we can show this as A dash B dash, right? And here object, you see its size is bigger here, but here we are getting image size smaller, right? So how to state this one properties? of this image here. So we can say when the object is beyond C, okay, nature of the image we'll write directly image. What is the nature? Nature is always again, what is that? Real and inverted. Real and inverted means it can be caught on a screen, and inverted upside down it looks, and inverted, okay, inverted. This is one property. Second one, what is the position of the image? It is between C and F, between C and F, between these points it is coming. Next, what is the size? Size, if you take, it is little small, right? So it is just called diminished. We call this as just diminished, right? This is how we can say when the object is beyond C, the image formed between C and F, it is real and inverted, and it is diminished. Okay, this is how we can draw, right? Okay, then after this, let us go ahead with next one. When object is beyond C, when object is at C, object at C. Okay, here again you need to understand this like this. Here, look at this. It's like this. Okay, the here F, here C you can show. Okay, if the object is at C, you have to show the object like this. That is A B, A B. You can show, right? Now you have to state what, write this as Mn. This is pole P, right? If you consider a ray of light, one should be parallel. Okay, one is parallel, right? The other, okay, it should pass through principal focus. It should pass through principal focus, right? As we have studied the laws of reflection, means rules for that drawing ray diagrams. If it is parallel, it should pass through principal focus, right? It should pass through principal focus, right? And if it is already passing through principal focus, okay, if it is already passing through principal focus, after reflection, it emerges parallel to the principal axis. We have studied this already, right? See, now what happened here? They are combining both the rays after reflection, right? Then we can say at this point we get the image. Will show here. See, okay, somewhere will show. Okay, here will show. Here what happens? Image we are getting. Now we can observe. Okay, what is happening here? This size of the image and size of the object both will be same. Okay, position is what? Position is at C. If the object is at C, image is also formed at C, right? Image will also be formed at C. So this is how we can get here. If you write image, what is the properties of image? Image, it is real and inverted again. Real and inverted. It is real and inverted. Second one, second property, what can you say? Here it's position. Position is at C. If the object is at C, image is also formed at C. Remember. Next, what we can say, size. Size, what about the size? Same size. Same size of as that of the object. Okay, same size as that of the object. Image size and this object size both are equal. Remember, right? This is how we can say this one. Next, this is when the object is at C. Now let us take next point. When about principal axis, you must remember whatever the light ray it travels along the principal axis, it follows the same path. Okay, you should show that all. Just object when it is uh, between C and F, object between C and F, we have to consider. What can we say here? Look at this. Here this is concave mirror, little bit, we'll take that side. Okay. Yes, you take this concave mirror. This is principal axis, right? This is the principal axis. Here, if this is F, this will be C, right? Now, between C and F we are taking. If you consider here object, say this is AB, right? This is mirror MN, this is pole P. Now, if you take any object here, you have to consider here one ray parallel you are taking, right? Parallel ray you are taking. Okay. After reflection, you should pass through the principal focus, as you know already. Okay, it should pass through principal focus. What about the ray? One more. Here you have to consider a ray which is passing through the center of curvature. You have to consider a ray which is passing through the center of curvature. If you consider this ray, it follows the same path after reflection. Okay, you know this already. If it follows the same path, what happens? These will come and join. Okay, so if you extend these lines, they join. Here they are joining, beyond C they are joining. Here you can see image. If you draw here, this is A dash, this is B dash, right? A dash, B dash. Now this image is again real and inverted. Okay, so if you say nature of the image, what is that? Real and inverted, real and inverted, right? Now you have to show these all the rays after reflection, how they are following the direction has to be shown properly, right? Here if it follows, here also it is coming just after passing through that, like that. Next you see here, this is F. Okay, and the rays which are moving along the principal axis, they follow the same path, you know this. Now for real and inverted, then position, what is the position of the image? Position of the image is beyond C. Okay, image is formed beyond C when the object is between C and F, remember. Okay, beyond C. Look at this. Next, what is the size? Size is enlarged. Okay, size, it is enlarged, means it is bigger or not. So we can say it is enlarged, size is enlarged, right? So this is how we can say that image is formed when object is placed between C and F. It is formed beyond C. It is real and inverted. Its size is bigger than the object. Okay, and it is enlarged. Position is beyond C. You know this already, right? Okay, this is all about when the object is placed between C and F. Now we have to come to know when the object is placed at F, what is going to happen. That also we must understand, right? So we'll come to know what happens when the object is placed at F. Okay, then what type of image do we get there? That also we must understand. So we will say when the object is at F, when the object is placed at F, what happens? Let us draw here. Okay, concave mirror, you have to show the rough surface, right? Now this is mirror MN, principal axis you show. Okay, this is principal axis. Here you have to show one principal focus, here center of curvature, right? Now we are going to place the object at F, so you have to consider here object. Okay, object is here, say AB object. Okay, now when you take one ray you are taking it as what? Parallel, right? Parallel ray you are taking, right? Next, one more ray you have to consider here, which is passing through the center of curvature. Okay, along the center of curvature you have to consider. After reflection, it follows the same path if it is passing through the center of curvature. And ray which is parallel, it should pass through what? Principal focus after reflection, as you know already, right? Now you can observe here both the rays, they are not up to the scale. If you draw them up to the scale, they will be emerging parallel. Okay, what is happening here? No image formation. When the object is placed at F, no image formation. What happens? It is formed. Where it is formed? It is formed at infinity. If it is formed at infinity, what will be the size of the image? It will be highly enlarged. Okay, so we can say here you have to show this all. Okay, after reflection, how it passes. Okay, this, if it is AB, okay, image, it cannot be shown here because it is formed at infinity. Remember, all these you need to show. Okay, now what we can say here, nature is, again, nature is same, again, real and inverted, real and inverted, real and inverted. What about the position? Position, it is at, formed at C. Image is formed at, sorry, formed at infinity, formed at infinity. Because you know that when the object is at infinity, image is formed at the focus, right? When the object is at focus, image should be formed at the infinity, right? These are laws. So what we can say, it is formed at infinity. Then what is the size? Size is, it is highly enlarged. What had happened in the beginning? When the object was at infinity, image we got highly diminished, right? But when the object is at f, then image should be highly enlarged, right? So we can say highly enlarged. So these are the characteristics of the image formed when the object is placed at f. Okay, next, last one comes, that is when the object is placed between f and p. Okay, what happens? That is very much interesting. Okay, now coming to this last, when the object is, when the object is between p and f, or f and p, whichever you write, and p, between these, when it is placed, what type of image do we get? Look at this. Here this is concave mirror, right? Rough surface you need to show, principal axis you need to show, this is mirror mn, right? So what happens, this is pole of the mirror, right? You know this already. So what we are going to have is, okay, now you see. Okay, in case if I have any doubts, you can ask, I'll be seeing, so that I can clarify and go ahead. Now you see here, this is principal focus, this is center of curvature, this is pole of the mirror, right? When the object is placed between here, between P and F, how to consider this one? Now you have to consider two rays. Okay, one ray you have to consider along the center of curvature, passing through the center of curvature you have to consider. Okay, now one more ray you have to consider, it is falling obliquely towards the pole P, as we have studied in rules of ray diagrams, right? If it is, one is obliquely falling towards pole P, one is moving along the center of curvature, and it is following the same path after reflection, you know that, right? Now this is AB image. Now what happens, this image after it is incident, okay, on the mirror, it is what, emerging obliquely. Just now we have studied the rules, right? So it is emerging obliquely. So what is happening here? This angle should be made same here. What angle it is making here, same angle should be made here also, right? So if you take like that, you have to, now you see you are showing this rays, okay, you have to extend these rays backwards here. If you extend these, what happens, these extended rays, where they meet each other at this position, we are getting the image. Look at this now, image, it is a dash b dash, how we are getting, this time we did not get this as upside down, we got erect image, right? So what we can say from this, here when the object is placed between f and p, we are getting here virtual and erect image. This only at this position it changes. Okay, what is the nature? Nature of the image is virtual. Okay, it is virtual and erect. See, only in this case it changes, all other positions, all it was just inverted and real, right? Now virtual and direct. What is the position? See, it is behind the mirror, right? position is behind the mirror it is. So behind the mirror, right? Then what is the size? Size is enlarged. Enlarged. Look at this. So these are nature of the image when it is object is placed between P and F, right? So now coming to this, let us uh, try to understand what are the uses of concave mirrors. Okay, then we have to learn that also, right? Next, image formation by convex mirror also is there. Okay, that also we have to study. But let us finish off this one. Concave mirrors uses. What we say is here concave mirrors are used in searchlights. In searchlights means what? In what prisons and all you might have seen on what in movies. What happens? One a beam of light will be just moving all around the campus there, right? So that is searchlight. In searchlight, powerful beam of light will be got there with the help of what? Concave mirror. See, like this, if it is there here, if it is searchlight, here bulb will be placed in this position, right? Look at this. With the help of this, it is giving powerful beam of light here, right? So this is searchlight. And same, it is used in headlights of the vehicles, and it is used in torches also. Same concave mirror, right? Then where it is used other than this, then by dentists. Okay, dentists, if they use small spoon like a mirror, they will use, right? That is concave mirror. When they place that behind the tooth, our tooth will be placed between the position of F and P. That is why erect image they can see, that is virtual erect image they find. So that easily they can see the enlarged image of the tooth there, right? Just by placing it behind it. This is one. Next, it is used as a shaving mirror also. What? Concave mirror, it is used as shaving mirror. Remember, okay? Means what? Enlarged image of the face can be seen. Okay, so that is used. Next, the same concave mirror, it is used in solar furnaces in industries to concentrate sunlight to produce more heat. They are using their large concave mirrors. They are using. Okay, they are concentrating so much sunlight so that so much of heat is produced. With the help of that, they can get their work done there in the factories. Okay, so that is how it is used. Okay, concave mirror. Then we have to learn about what? Image formation by convex mirror also, right? So convex mirror image formation. Before learning that, if you have any doubts, you can ask me. Otherwise, we'll go ahead. Okay. In the next class, we can take, it becomes little longer video anyway. Okay. Anyway, image formation by convex mirror, we will see it in the next video. It's very simple. Only two positions will come there. One is when the object is at infinity. When at infinity, where that image is formed. Okay, you know that it should be formed at focus, right? And what happens? And one more, when the object is between C and no, between P and infinity, means pole of the mirror and infinity. When the object is placed in these positions, what type of image do we get? That also we are going to learn. Okay, this is how we are going to learn. This is all about here. So far we have learned in detail. In case if you have any doubts, you can ask. Okay, you watch the video completely so that you can get clear understanding of the concepts if anybody is in need. Okay, so this is all about what? Concave mirrors, and mirror formula comes, its application comes, its problems come. In case if you need, if you understand these concepts, you can ask me so that I can go ahead with that. Shortly we will come live and we will solve those problems also, which involve based on what mirror formula and magnification. Okay, you come to know that also will solve. Okay, you watch the video, and again I'll see you in the next live stream. If you are in need, you can comment and ask, so that I can take that particular topic of your class, whatever it may be, science. Okay. In case if it is maths also, we'll take, no problem. Okay. So see you in the next live stream or next video. Okay. Bye then.